So the following questions refer to the vectors u and v and w. And the first thing we need to do is sketch a vector A, which is the addition of u, v and w, and then actually solve for what A is. So before we get to that, let's just sketch each of these vectors individually. So if I start with u, we've got 3i minus 1j. So it's going to have a positive x component and a negative y component. So I'm going to guess it looks something like this. Next we have v, so it's got a negative x component, so it's going to go backwards, and then a positive j component, so it's going to go up. These probably aren't going to be very to scale, but that's kind of what I would expect v to look like. And finally for w, we've got a negative x and then a negative y, so I'm going to expect it looks something like this for w. Alright, so let's actually go with part A now, where we have to sketch the addition of these three vectors. So u, let's start with that one, looks something like this. We've then got to add v onto it. Remember, we do it head to tail, so the head of u now touches the tail of v, and then we need w to come back. Something like this. Alright, again the head of v touches the tail of w. So the resultant is what happens when you go from the very beginning of your chain all the way to the end. In this case, I think what we're going to find when we solve it is that they kind of touch at the very end, but we'll prove that. So let's go ahead and find this vector A. So it's equal to v plus w. So we can substitute in these versions of our vectors. So 3i minus 1j, negative 2i plus 4j, and then negative I minus 3j. Alright, so looking at this, we have, for the I components, we have 3i minus 2i minus 1. So it's going to be 3 take 2 is 1, take another 1 goes back to 0. So they're all going to cancel out with each other, leaving us with a 0 I component. For the j's, we've got negative 1 plus 4 minus 3. So again, that's going to cancel out. 4 take 3, take 1, that goes down to 0. So therefore, overall, vector A is equal to 0, which is why it kind of joins up at the end. Alright, so let's go with B now. So this one we've got 2u minus v minus w. So we'll start with drawing the sketch again. So 2u means that we basically have double the length of this in the same direction. I'll just draw it as 2u's though. So something like this. We've then got minus v. Alright, so if this is normal v or positive v, when we have the negative of a vector, all that happens is we change the direction of it over. So this would be negative v. Okay, same length of the vector, just the opposite direction. So that's what we need to add to the end, this vector here, negative v. Alright, and then finally we have minus w. So again, we can just flip this over. So minus w is the same length vector, just opposite direction. So let's pop that on. Alright, so this time it doesn't look like we've joined up at all back to the beginning. So we're definitely going to have a non-zero answer for this vector b. So that's like the resultant. So again, we start from the very beginning of our chain and we join it up to the end. So that is B. Alright, so now we just need to go through and actually solve for it. So we have our expression that we can kind of sub into. So B was equal to 2u minus v minus w. Alright, so we have u, it was this 3i minus 1j. Minus, we got to take away v, which I'll just substitute this in. That was what v was equal to. And then minus again, whatever w was, which was this. Again, I'll just recycle it. Save scrolling. So let's expand out those brackets just to make it a little bit easier to process the numbers. So 2 times 3 gives us 6, and that's an I. 2 times -1 leaves us with -2, and that's a J. We've got a double negative here, so it's going to turn into a positive. 1 negative, so it becomes negative. And these are going to have both double negatives as well. Alright, so now we just need to collect the i's together and the j's together. So starting with i's, we've got 6 plus 2, that gives us 8, plus another 1, that gives us 9. And then for the j's, we've got -2 minus 4, that leaves us with -6, plus 3, that's going to leave us with -3. And if we have a look at our sketch and try and relate this to our sketch, it kind of looks like it should. So we've got a positive I component, and we can see that B has a positive X component as well for this vector. And then we have a negative J component, which means it should go downwards in the Y direction, and indeed we have that happening. And even though my sketch is not really to scale, we can see that the X component is a lot bigger than the Y component, again, which is what we've got here. So that will make sense and is all good. Alright, so we're up to part C then, which is to determine a cross product. We want W crossed with U. Alrighty. So we can substitute in our W and U vectors. Again, I might just steal them from over here so I don't have to scroll up. So -I minus 3j is getting crossed with this one here, 3i minus 1j. So I'm going to use our little diagram with the I and j and k with the arrows in order to multiply this out. Remember that if we do a cross product in the direction of the arrows, it's going to be positive. If you go in the opposite direction, it's going to be negative. The other thing to remember is that if you have a vector crossed by itself, it's going to be 0. So I cross I and I cross j, and j cross j are equal to 0. So the first one we've got is -I crossed with 3i. So that's going to fulfill this first one here, where I cross I is equal to 0. So I'll pop that in. Next we have -I crossed with -j. So we'll deal with the numbers first. So there's a 1 in here. So -1 times -1 leaves us with +1. And then I cross j, looking at our diagram, that's in the direction of the arrow, so it's going to be a positive. And we get the other one out, so that's going to be a k. When I say the other one, I mean if we're looking at multiplying i's and j's, the other one would be a k. Alright, so next one we have -3j crossed with 3i. So that's going to be a value, it's not 0. So -3 times 3, that's going to leave us with -9. And then we have j cross I. So we can see that's the opposite direction to the arrow. So it's going to be a negative. That means we have a double negative. So it'll be positive. And we get the other one out. So again, since we're looking at I and j, the other one is k. So the last piece to multiply out is -3j crossed with -1j. We have j cross j. So that's going to end up being a 0. So putting these together, we end up with an answer of 10k for that cross product. So we're up to the very last part of the question, part D. This one wanted us to find v dot w. Alright, so we need to go and slot in v and w. Let's just go find what v was. So -2i plus 4j. And w, I'll steal it from here. Alright, so they're getting dotted together. So remember, for a dot product, it's kind of the opposite of this. So all we're looking at is actually multiplying together the i's and the j's. That kind of implies that when you have an I and a j dot producted, they end up being 0. So let's give it a go. So it's going to be -2 times -1 for the i's, plus it's going to be 4 times -3 for the j's. So this works out to 2 that works out to -12. So overall, this is going to end up being -10. So that's all there is for that question. See you in another video.